Hello everyone, I'm Monika Bhushan and today we are starting new topic which is numerical methods. Okay, so under numerical methods we are going to study finite differences. Okay, so before jumping to finite differences, we will first understand the concept of numerical methods. So we will discuss that what is actually numerical method and what is the need of numerical method, why we are studying this numerical method. Okay, so there is some reason to study this numerical method. Fine. So when we use numerical methods, so there are some problems that we deal. Those problems don't have the direct solution. Okay, so maybe the solutions of those problems are not well understood, right? And for the solution of those problems we need to take help of some guesses, and then we just test that okay whether we got the solution or we reach nearly to the solution. So those type of mathematical problems or even those type of real life problems can be solved using numerical methods. Okay, and sometimes what happens that indirectly we use numerical method to solve any problem, and we only don't realize that we are using a numerical methods. So what is the other method which is not numerical, right? So there are two types of solutions or method which we can say. One is my analytical method. Okay, so one is your analytical solution of any question, and the second one is called the numerical method. Okay, so before coming to mathematical problem, let us discuss some day-to-day life problem where we use analytical solution or some problems where we use numerical solution, right? One example of analytical solution will be like you have to get the degree. Okay, so to get the degree you have to clear your all papers, and then if all the papers are clear you will get degree. Fine, so the step to get the degree is well understood, but now we'll talk about the problem where you need numerical solution, where exact solution is not there. The problems will be little complicated and you use some iterative method to solve problems. Okay, and what could be one example? Suppose you have to clear your paper M2 and you know that the passing marks is 32. Okay, and then you really don't want to prepare for 100 marks. For that what you will think, you will first decide that okay I'll do just module 1. Okay, if I'll do module 1 I'll get maybe 16 marks. Okay, but just preparing for module 1 will not make me clear my paper. Okay, so I'll again go for some other module, maybe module 3, so it will be your 16 plus 16 32 marks. But still you really are not that sure that complete 16 marks in your module 1, complete 16 marks in your module 3 will make you clear your paper. Then again you will go back to the syllabus, again you will check that which another module I will try, maybe not complete but half. So iteratively you are actually deciding, and then you will check that whether you are close to 32 marks or not. And suppose you are trying another module for just one or two questions more, so that you are preparing for 40 marks, then you will think that if I'm preparing for 40 marks, then I will get 32 marks. So here I will stop. I will not again prepare for any other module or for any other question. So this type of solution is example of numerical solution where you don't have the exact answer for that, because here also you are not 100% sure that if you are preparing for 40 marks you are really going to clear your paper. You think that yeah you are going to clear the paper, or maybe even preparing for 40 marks, if you are getting 32 marks you are happy with that. That means even the difference of 8 marks is okay for you, right? Now let us see some mathematical problem. We use analytical solution, and then we'll just see some mathematical problem where we will use numerical solutions. And this complete playlist is under numerical methods only. Okay, in analytical solution we can give one example of solving quadratic equation, right? If I'll say that some equation I'm writing down, x square minus x minus 6 equals 0. Fine, and you know that you will get two answers of x. Fine, the roots will be 2. So one will be your x1, and the second answer will be your x2. And after solving, you will be getting the answers as 3 and -2, because you know the method. Either you are going to factorize it, or you are going to use the formula of quadratic equation, and then you will get your answer. But if you are solving this equation, or your friend is solving this equation, all will get the same answer. You will get the exact answer. The answer will be 3 and -2. You are not going to say that, yeah, I got 2.99 instead of 3, and I got -1.58 as my x2. So no, this is always the same answer, 3 and -2, if you are using the correct formula and correct method, right? So this is the analytical solution, where you are going to get the exact answer. The answers will be correct, okay? But not always my problem will be straightforward. That means whether I have to use analytical solution or numerical solution, this depends on the nature of problem also. And sometimes if you are dealing with some definite integral, suppose the limit is from a to b, and some function fx is given to you, and you have to find the integration of it, and this function is unknown to you, okay? That means you cannot use just the formula for this function and you will get your answer. For that, you have to go to this approach, which is called as numerical solution. Like how we discussed, that you are going to check whether this much effort is okay to get my answer, whether this answer is good enough, whether this much of error is allowed for me. So these things we actually perform to get the numerical solution. Right, and we deal with many differential equations which cannot be solved exactly. For those type of differential equations, they are actually non-linear ordinary differential equations. So we have to rely on numerical solutions to get the answer for those non-linear ordinary differential equation, okay? But we know that the numerical solution will not be exact, okay? You and your friend will get answers which may not be same, right? But we will be okay with approximate solution also. Some amount of error is allowed. So why we go for this numerical method? So the reason is that in many questions, the analytical solutions will take too much of time. So that much of time we always cannot give. Okay, and some problems are very complicated, so that we don't have the straightforward formula to solve them. And if we are going to use numerical solutions for those questions, we might be dealing with some simple operations, and then we will get approximately, we will be getting the answer. So those types of problems we are going to see in this lecture series. Fine. Okay, in next class we are going to see finite differences. Fine. If you find this class useful, please like and subscribe my channel. Thank you.